In this video I'm going to show you how I made my latest anvil. It was a lot of work, it took a long time, but I learned the process of on how to do it. Most of the material, all the materials I used were recycled materials, no new material except for the electrodes and the grinding and the flap discs. I use something like 22 or 23 kilograms of electrodes to do it, and let's see it.
Hello YouTube. Even though in one of my previous videos you saw that I made a nice anvil based on the chisel of an hydraulic breaker of a tractor, I still don't have a good RD tool, so a friend gave me this bit of steel. The surfaces on both sides were very irregular. It was cut with the oxyacetylene torch, and I already cleaned the surface from the uneven cuts. In some places I just grinded with an ordinary grinder, and on other places I just add some beads of 70-18 rod. You can see here in some places only a few millimeters correction. I had to add material. In some other places I had to go a bit deeper, like 20 millimeters. And now the idea to make the anvil is to be some sort of striking anvil. Lots of ideas on YouTube on how to make striking anvils. Alex still started this idea, and I have this block. It is 160 millimeters diameter. It is 196 millimeters tall, and the idea is to put here these two bits of flat. Okay, these two bits of flat over here. Oops, sorry. They are 25 millimeters width here, and I'm going to put them 25 millimeters apart. I'm going to use this bit of square tubing, okay, just to measure, and as the back part I'm going to use this bit of steel I got at the scrap yard. It is ordinary mild steel. This is mild steel. This is mild steel, made of 40 millimeter thick. I didn't have any other way but to cut this bit. I tried with a torch of a friend. The torch was damaged, and we had to cut it with the angle grinder, with the 9-inch angle grinder. There are some holes. This is some part of some old die, and I'm going to plug these holes with here small bits of 8 millimeter rod. Okay, here there are here there is some threaded. It is from the other side. Half of the holes are threaded, so I had to clean the threads from these bolts. Okay, and to plug here with this big bolt and cut it. And let's take a look on the other side. It's not completely flat, but this is what I have, and I decided to use material from scrap to make this stuff. And let's start and see what happens. I plugged the holes that were here on this bit of steel plate. Now I'm going to grind flat the excess material, and I'm going to weld over here the two sides of the hardy hole. Okay, this bit and this bit. Okay, and this then goes over here on the cylindrical block of steel. Now the two sides that are completely flat and 90 degrees are this side and this side. These two other sides, that's where I cut, and they're not perfectly flat, and they're not 90 degrees. So let's do it and see what happens. Now this is the setup I have before I tack weld here. These places here are the marks to center the hole. You can see that I have here bits of 10 millimeters flat stock, 25 millimeters wide, and I build these chamfers so I can make full penetration welds. Okay, wish me luck, everything is going to be nice and straight. Okay, you can see the two bits of flat stock is welded over here. The idea is now, is now to have this face over here flat with this face. This will be the hammering face. This is just a reinforcement for the back side here of the hardy hole. I will fill up this with material with 718 and bits of steel like these beads. And the stock here is longer also at the bottom. After I lay here some beads, I'll just cut the excess material so everything will be nice and flat. And eventually I'll fill up here this material that was milled here from the plate. But we have here a problem. It's that the face over here is convex. So I marked here these two places. From here I'll lay a few beads of to make it flat and grind it until it is flat, so everything fits here flat. Now no doubt this is a lot of work just to make such a project. I can use this as an ordinary anvil to hit it with a sledgehammer, but well, I enjoy doing this stuff, and now I have myself a brand new toy, a three-phase welder, stick welder, three-phase 380 volts, 300 ampere. I can weld with up to 5 millimeter rod. So this is a way of trying it and improving my welding skills. Okay, I laid here some beads and I flattened it using a flap disc and this stuff. So this is more or less straight. Well, sort of straight, and also in this direction as well. Okay, if you see. And now I'm just going to fix here the edges and spot weld this into here. Okay, the two pieces are aligned. These surfaces here are also aligned. Okay, here and here. Then they will be corrected, and this is the way it looks inside. And now I'm just going to tack weld here, and wish me luck. Tack welding here the other side using the square tube to work as a stopper for all these components, all these parts to stay in place. I'm laying here the first bead of welding, and I'm using 6010 rod here, and I'm using the technique that I weld a small segment like here, and then I'm welding furthermore, and I'm also alternating between sides. And so now I'm going to weld over here, then I flip the anvil and weld the other side to avoid the wrapping or to avoid the the square hole to change dramatically. We reach this point so far welding, and you can see here there are several layers of beads, and the hardy hole here is sort of squarish. This is 10 millimeters thick. Here there are more or less 20 millimeters of beads laid one on the other. I think that I got to a stage that I can this is a bit of a bar. This is 30 wide by 10 millimeters thick, but I can make here a chamfer and lay it over here straight, more or less like this way, and this will give me a space to weld on both sides, and it will save a lot of time welding here. And let's try it and see what happens. Here it is, the bit of flat stock where I made the chamfer, and then I welded this into place. It's going to save me per each side something like 20 to 30 beads of welding. Okay, let's keep on welding. You can see here that I added a little bit more of stock. Okay, let's see here in detail. This is the bit of stock that I added previously. This is the stock, round stock 12 millimeters that I just laid the future to be anvil on a flat surface, and I welded with, let's see, with a gap. You can see here the gap. Okay, you can see here the gap here. Now I want to weld in here with to fill up this gap with the 60-10 rod. Okay, I managed to fill up here with beads all this space. Okay, and now it's time. I fill it up everything with the 4mm 718. And now it's time to start cutting here these edges of these bits that I used to fill up these spaces, and I'm going to start grinding here with the grinding disc and the flap disc, and with the sandpaper these areas, so everything will be nice and smooth. Now after cleaning here the edges, you can see more or less how the anvil looks like. Okay, this is Joseph the crow. He's asking for food. I took a piece of cardboard and made a contour. Let's see if you can see it. I don't know if this is clear. I made a contour, okay, like in this position. I laid the cardboard here, and then I made a contour just to figure out more or less what is the general shape, what's going on over here. You can see clearly that during the welding process, because of the heat and the contraction of materials, the plate is slightly bent. That was expected. And of course the edges are here that they were flat with this tangent here. They were in a single plane. They are like converging now. Okay, and you can see here this is more or less. Let me grab something long. I don't know if you can see clear this, but this area here bent more. This area over here bent more. It is represented in this bit here in the paper, in the cardboard, because we are here lacking material, of course. Okay, so it was expected that this would bend more with the heat and with the contraction of materials. Okay, and as a result, the RD hole is sort of square, but it is a bit misaligned. Okay, it's the length, it's the same 25 millimeters. The width is the same 25 millimeters, but it is not perfectly square. Joseph the Crow. Okay, in this direction it is 32 millimeter long. In this direction it is 34 millimeters long. So it is like compressed like this way. This is due to two facts. First, probably the preparation here of the hardy hole in the cylinder was not good enough. Okay, and second, because I used here two bits of flat stock, 25 millimeters, that I placed here, they simply, with the heat and all the materials bending, just bent in this direction, that where the back plate bent more. And this is a lesson. Next time I think that it is suggested to take like a block of steel, machine a block of steel, like, okay, with an angle, with a chamfer that can be welded, but with a built-in already hardy hole to avoid this movement, relative movement of the plate in relation to the main body of steel. Let's now fill up all these, lay here some beads, make everything flat and nice, and just lay here a few beads. Okay, everything flat and nice. Let's see what happens. I suppose that the hardy hole will work like this way. Okay, this is where I got so far with the surface of the anvil. I measure here the straightness of the surface, and you have to believe me that here I have this is deeper here in this area than it is on this area. This is more or less flat, this is more or less flat, and here is a bit concave. So I'm going to lay here one layer of beads and then grind it, and hopefully everything will be more or less flat. I plugged here with a bit of wood the hardy hole, so I can weld here around without the material going too much inside and give me a lot of work then later on to clear it. Okay, the layer of beads are made already over the depression that was here. Let's start grinding it and see what happens. The surface is I grinded the surface, and it is more or less flat. You have to believe me. I checked it with a ruler. Now, okay, more or less the sides more or less to fill up a little bit, and the bottom I want to more or less. This here is a bit too long, like 3-4 millimeters longer than the rest of the piece. I just want to grind it out and put some legs, and that's it. As you can see, here it is, Joseph the Crow asking for more food, of course. The hardy hole is clearly skewed, and well, it will have to work like this way. Thanks. I finished welding and sanding and grinding and sanding all the sides. As you can see, here it is more or less flat. Here it is flat on the side. Here it is flat on the back. I didn't finish yet welding these beads. Okay, at the bottom it is also. It weighs around 50 kilograms now. Give it or take 2 more kilos. Here it is also not till the end, but this is going to be the bottom part. And if I got this far, so why not put here 2 horns? I thought on an angular horn. I made this maquette in with the serial morning cardboard and this in paper. It will look more or less like this way. This is here 17 centimeters, 12 deep and 14 like this way. This is like 13 centimeters diameter here at the base and 20 centimeters long. And the materials I'm going to use to make these two horns will be a bit of the plate, the remaining of the plate that I used to make the main body of the anvil. I need to cut here, and this is for the horn. Now the horn at the base is going to be like 14 centimeters diameter, the round horn, but here this is a small plate, so a small round stock, so I'm in both cases I'll have to make like a first skeleton, and then fill up the gaps with welding other bits of steel and so on until I have both horns complete. This is so far where we get with the fabrication of the horns. I'm cutting here the stock for the angular horn with my super tools, the grinder, the 9-inch, and this is a 4.5-inch. And this is the original stock. I cut the round horn. The idea is to put like this way. Okay, this is a plate, comes in the middle. Okay, I hope you get the idea. Okay, and let's do it and see what happens. Joseph the Crow is here to help us, so let's see what we have to do. I made this template to find here on top of the table of the anvil, the main body. Sorry about the light, but you can see here there is the center line, and the idea is just to locate this over here, mark the center line, okay, then mark the center line here on the working table, so I can find exactly the position where to put the horns, both the round horn at the front and on the other side the angled horn. You can see that I cut the top bit for the angular horn, or for the tail of the anvil, as you want to call it, but because I'm using material, the leftover material, I have here the place where it was cut. I cut a bigger chunk to make the main body of the anvil, and I had here these cuts, so I brought a thicker grinding disc and I open it a little bit more, and later on with the you can see here that I welded here with 6010, okay, in the deeper place, and then intend to cap it with the 718. Okay, here I left to fill this gap. This is a bit hot, so that's why I'm not touching. Okay, and this is the bit, if this stands like this way, this is the bit that is supposed to be here, slant. This is going to be the structure or skeleton, as you wish, of the rounded horn. I used this bit of flat over here to leave a 4 millimeters space here, so to allow me the full penetration welding, and here is the setup to start making the skeleton for the angled horn, or tail, or whatever you want to call it. Okay, it is going to be something like this way, and I already filled up here this gap that was lacking of material. Okay, let's start the welding. Now you can see the angular horn, the two bits are welded, just tack welded here, I'm going to make the first bead with the 6010 on both sides, and keep on welding, and with the 18. For sure this top bit it's going to bend because of the heat. Probably this is going to approach this part. I'll try to avoid it by welding the same amount of beads on both the sides, and let's see what happens. You can see there is a gap over here from this construction. So now I'm going to add here this bit of 12mm stock. Over here there is a gap over there that I'm going to fill with 6010. The skeleton for the square to the angular horn is ready. As you can see now, this bit over here, this part, is going to be welded here to this part of the anvil. I scratch here this line on the working table so we can align. Okay, just a moment please. We can align more or less here. This is the skeleton for the round horn. Okay, this is still hot. I need to trace here the middle. This has to come here over this line and weld here. Sorry about the glare, I was in a hurry. As you can see, I already tack welded in place, okay, with the spacers, the horns. Okay, but because I was in a hurry, I forgot to put here underneath a spacer underneath the round horn, because I want a small step between the main body of the anvil and the round horn. And let me try single-handed to lay down here the anvil, so you can see here they are leveled. There is no step, and I'm going to have to I want just to cut here these tack welds, and then weld this horn like a few millimeters or 15 millimeters or so lower than the main anvil body. I made the first root pass for the angular horn, and here I already reset. This is where I got so far. Sorry, I ran out of memory in the camera, and this is where I got so far. You can see that I already laid here a few beads now to connect the angled horn here to the body of the anvil, and this is the skeleton so far already welded here. The skeleton to make the round horn bigger. Okay, this is the plate original that you saw already. I added here these two bits of flat stock. This it is more to organize the work, so I know where I can lay the beads, and more or less to organize, and then with the grinder I can grind the excess material. Okay, and let's listen to the sound for the meanwhile. Okay, it rings a bit. Here of course rings much more. I think this means that there is a good connection between the different parts of steel without major gaps. Let's keep laying beads and see where we get. Oh, I almost forgot to explain. After I set the horns into place, okay, I decided, and when I thought that they were straight enough, I decided to scratch here with at full length. a line, and then when I lay beads, you know, I can come here, take a look at the alignment of the different lines and see if I continue to work to keep all the components aligned here with this center line in the main body of the anvil. So like this way I can decide if I lay here 1 or 2 beads according to the movement in this direction or that direction of different horns. This one is pretty stable now. This one, it still swings a little bit after welding, and this I think will avoid to get a result similar to this hardy hole over here that is skewed and not entirely square. After welding 5 kilograms, probably shell 18 rods, I'm using 4mm and 3¼ rods. This is what my machine can use comfortably. I almost close here the gaps. Okay, here for the square horn, the round horn, it's it starts getting more fat. Okay, it is not just a skeleton that is here. And then I'll have to start grinding all this excess of metal that I have here, but I'd like to reach this width at the base for the horn, so it is strong and it's not going to break on the first hours of work, of hammering. I have to start smoothing everything, and let's see if we manage to see over here the guidelines I draw over here. Everything is pretty straight, so let's keep on welding. This is where I got so far. You can see here almost finished welding all of this. I need to fill here these gaps, make it smooth. Of course I need to complete here the horn, and I'm grabbing here a cloth, so a rag, so to avoid the glare. You can see the line, the center line I draw to guide me. It's more or less straight, so this means that this horn is more or less straight. Here, see, I still have a little bit to grind here in this area with the angle grinder and smooth everything. We are almost there for this square horn. The anvil is now upside down. I'm already welded here this is the bottom part or the down part or whatever of the angular horn, and okay, the anvil upside down, and as usually I do, I set here like this bit of, let's call it a skeleton, so I have an idea, and I have you know, some way on. I have to fill up this now with material, with weld or other bits of steel. And here, this is more or less a slope, and then this here, this part over here will be shaved, will be ground over here to make the horn more horn-like. This is how far we got here, laying beads in the rounded horn, and now I'm going to use the angle grinder to define better and to round a little bit more these bits of metal that I welded here, and try to understand better what is the, you know, try to round the whole thing here in the edge more, to try to see better how it's going to be the final product. After a lot more welding, managed to complete. The anvil is upside down, of course. I managed to complete here the angled horn or the tail or whatever you want to call it. Now this it is cut here, the bit of metal. To make it a bit more elegant, I'm going to add this small bit and fill here with the 7018 rod, okay, to make it a little bit more elegant. Then I have to, of course, grind all these surfaces over here so everything is nice and smooth. Now this is the rounded horn, and it is I've progressed a little bit more, and I intend to make it round here in this area. I'm just going to add this bit of mild steel. I suppose this is 16 millimeters or 80 millimeters, something like that, and weld it like this way, and so I can make round here the bottom of the horn. The bits of metal are added. Here it is a little bit more of the skeleton. This is the gap that I need to fill up, and then fill here with weld and grind everything to starts looking more like a rounded horn. And here it is the bit of the tail, okay, and need to grind like this way as well. And let's continue. As you can see, I almost completed the horn, and now it is time to start grinding, okay, from a different perspective. Horn is more or less like 120 millimeters wide and 120 millimeters tall, thick, and it is now time to start grinding. The current weight of the anvil is 69 kilograms. You have to believe me, I just weighed it on the scale. And to grind it, I'm going to use the 115 millimeter flap disc, okay, and the 180 millimeter flap disc. And then to smooth everything out and straight, I'm going to use this disc, okay, with sandpaper, with the big grinder. Let's start. Let's start and see what happens. This is the horn after grinding. I'm making the first pass of grinding with a 40 grit flap disc. You can see here the high spots and here the lower spots. And now my idea is to fill up with the welding these lower spots and grind, keep on grinding until everything is smooth. Here the angular horn, it's in the middle of halfway of this procedure of smoothing everything, and I still have to add a little bit material of here. This is like the concave more or less in here, and here at the top of the horn I'm lacking some material. You can see here for the horn, the top portion of the horn to be parallel to the surface of the anvil. I need here to fill up this gap. Let's see, that's what I'm going to do now. This is the horn, the finish of the horn halfway done. It is fairly smooth. There are here these marks that I made, that place where the horn is more or less flat, so to make it more convex round, I need to lay here a few beads, okay, a layer of beads, so I can grind it round. Okay, let's keep on working. This is the anvil almost done. You can see I just ground everything smooth, and let's go and measure it. It is 65 centimeters long. The length of the horn is 23 centimeters, of the body together with the tail or the angular horn is 41.5 centimeters. The length of the tail angular horn is 19 centimeters. It now weighs, I weighed it before starting the video, it weighs 69 kilograms. It is like 195 millimeter tall, and it weighs 69 kilograms currently. I used more or less 22 or 23 kilograms of electrodes of 70, 18 and 60, 10 to make this anvil throughout all this process. It took a long time. I had weeks that I didn't make it, but it took like 6 months to build. Like 2-3 days after the afternoon per week, sometimes one whole day during the whole weekend. Was it worth it to make the anvil? Well, I suppose so, as an experience, just just to see that I was able to do it. It was okay, and all the process of making the anvil, it was a process of curiosity and try to understand what's going on. I hope it is strong enough and will not be damaged or break any component soon. Now you can see here all these marks with a little bit of the corrosion, and then I sanded this. I used a sand disc, and you can see, and let's see how it rings. It rings more or less okay. So this means that the welds were more or less okay, and that there are no too many empty spaces in the inside, and otherwise it won't ring like this way. Now let's compare it with my small 14 kilogram anvil. Pick it up. This is the small 14 kilogram Brooks anvil. Let's see the rebound. Podes ver aqui. Let's see the rebound. Okay, you can see a fairly nice rebound, like 80-90%. Let's compare the rebound here with the mild steel anvil. Of course, not as good as a steel anvil. Okay, it's okay. Now that's enough for this video, and if I got here so far, if I did this and invested so much work, I have plans of going to the electrode manufacturer and buy some hard facing rods just to harden this area, increase a little bit the rebound, and avoid even I don't know if you can see, but even from dropping the steel ball it leaves a small mark. I'm going to weld some feet on it as well, and some long feet, so it is ready to set it on the floor and to start working with it. And I hope you enjoyed the video, and please leave your comments and suggestions, and thank you for watching.